So let's start then. So today we'll have a lecture related to the general principles of object-oriented design. We'll cover a couple of topics related to the solid, dry, YAGNI. These topics usually asked during the interviews on the junior, middle, and even senior positions. So that's something you need to know to be the Java, or even not Java, but software engineer who works with modern object-oriented languages. So today we'll try to be quite fast because at 11:45, Sergey Tatenko will come and with a short demonstration of his book. And also we will just overview these principles. So no classwork is expected today. Also, we do not have a homework assignment. So next week, you can spend on the closing of uncovered on unfinished homework assignments from your part, and also focus more on your final project. So it's just a theoretical lecture. And yeah, let's go one by one. In the end of the lecture, I'll also share the main important dates for our course. Yeah, so just imagine you have a simple app. You already worked with UML diagrams, and from this chart, you can see that we have the custom application, which works with the chats. It implements the logic for the chat and messages controls. And what we have the application itself on the top. The application may have many chats, many chat controls, and many messages. Well, message control and chat control realizes a vertical box. Chat control has chat click handler. You probably remember it from the previous lectures we had. And chat may have many messages. And message control has one message in it. So we'll try to revise this application through the sum of solid principles, and try to refactor and understand how to build it and to follow a single responsibility and at least a dependency inversion principle. So we have a couple of design principles we need to follow during implementation of our app. They are all related to the object-oriented design. You should know them and should try to practice. It's a KISS, YAGNI, dry, and solid. Here, I would like to ask for your proactivity, and if anyone knows about anything about them, please feel free to raise your hand or just speak directly into the microphone and try to explain what does it mean if you already know.
I think dry principle is when you don't need to repeat your code. So like using
Don't repeat
functions.
yourself. Yes.
Yeah.
Okay, what does it mean in your application when you are working with the sources? Well, probably don't repeat yourself. It means do not duplicate your code. So use it in one place, try to keep it, avoid duplications, right? And extract into the separate components to divide it by the responsibility. Yeah, we will cover it later. Good. Anything about others? Is YAGNI, Solid, any ideas? Well, KISS probably it's not a KISS. It's just an abbreviation. And yeah, just go one by one quickly. So KISS, it's an abbreviation from the keep it simple and stupid. What does it mean precisely? Do not overcomplicate your solution. If your class design is simple, it would be better than overcomplicating and adding over engineering functions. So if you implement in the chat application and you do not need to provide files or associate anything else, just the messages, don't over engineer at the first stage. Implement as simple as possible. And then if there is a need, extend it. So it should be simple. It should be readable. it should be understandable. So your class structure, your set of methods, fields, and interactions with other entities should be clear and understandable. Do not overcomplicate the logic. Do not implement the classes with 1,000 lines of code, because it makes it unreadable, and it would be hard to refactor and to understand what is going on under the hood. So generally, it means we need to have a simple class design. We shouldn't over-engineer. It should be readable and understandable. And try to use encapsulation, but not obfuscation. So encapsulation, as you remember, it's one of the object-oriented OOPA principles to encapsulate the logic, make it hidden for the outer world. And obfuscation means to organize your code in not readable manner. So it should be clear, it should be understandable. Encapsulation means that we are using the dependent objects as the fields, and they should have their own zone of responsibility, and we can reuse them. Is it clear? I believe yes. Let's go to the next one. Yagni. Well, it's not only related to the software engineering, it probably relates to all kind of engineering activities like electrical engineering or military engineering, but it's also widely followed in software engineering practices and object-oriented design. Yagni means you are gonna not need that. So usually people are adding some extra features just in case, and build complex class hierarchies or abstractions before there is a concrete use case. Well, focus on the current task. If you have a chat, as I said before, if you have only messages, just implement it. And if there is a business case to add some integrations, videos, images, then it would be a right time to extend your logic. So your logic should fully satisfy current requirements. Do not overcomplicate it, and do not build the features for potential use. In my practice, with the highest probability, these features probably might not be used if you implemented it just in case. So your logic, your implementation should satisfy the business needs just right now. What should we do? You should focus on the simplest solutions that solves today's problem. If you'll be working as an engineer or in other roles, you'll be probably working on the finalization of the user stories, tasks, and that's something which resolves the problem right now. So if you have a concrete requirement to finish with kind of a user story to satisfy the user story requirement, then just focus on it. Do not implement something which is not needed right now and probably will be needed somewhere in the future. Also, refactor or extend the system when a real need arises. So about the refactoring, well, it's probably you know what does it mean, yeah? What does it mean refactoring?
Probably changing the file tree, file structure of the project.
Actually, it's providing improvement. So during the lack of time of work with your daily basis activities, you may miss something. You can provide some technical depths. So for example, missing comments, missing tests, using the old library, using the hard-coded values, and so on and so forth. Well, from time to time, they are accumulating, and it's really important to change it. But in your work, it's always good to have a balance between refactoring and real business activities. In my practice, it's a good and common case to have 20% focus on the refactoring and technical improvements and 80% of real business use cases implementation. Yeah, all of technical depths, code smells are accumulating. That's a normal practice. It's also required to refactor. And here I'm saying that refactor or extend the system when a real need arises. So what does it mean? We are not refactoring the whole iteration of the development. We should keep the balance. And if we are extending the system, we need to understand why we are using it. So, for example, we are providing integration with Instagram just in case. That's not something following the YAGNI. If we have the business need to do that, then we are trying to implement this use case, but not in advance just in case. Here, I think it's clear. Yeah, dry. Already mentioned, don't repeat yourself. It's really important because actually the key, the main idea of the object-oriented design, object-oriented principles, just to split the logic by using some kind of classes like an entities and provide the interactions among them. So we are splitting the logic, we are associating the logic with some of the business entity like car, people, student, university, and so on and so forth. And we are reusing them in a multiple locations. So first thing, reusing method and classes. Don't copy paste, don't extract the logic from one place and use it in another one. Just think how you can compose the components and keep the implementation in one place and use it in multiple places. In case you're copy pasting, you're providing multiple points of attention later on, and you need to, in case you're changing something, you need to change in multiple locations. It's not really effective way of working. Just try to organize your code in the way that business logic is collected and implemented in one place. Next one, moving shared logic to utility or service classes. Well, for example, you have a date formatter, and the date formatter is following some principles. So it should be time, like an hour, minute, second, then the date, months, and the year. This format thing is being used all across your application. Of course, it does not make sense to use this formatting rule in every place in your app, which works with the date and time. Use shared classes or shared even libraries. So for example, in this case, you can create a static class with a static method and reuse it in any place in your app. Yeah, applying inheritance or composition where appropriate. So that's what I said before. Use your logic in one place, in one class, and try to work with the components and do not extract the parts for in other classes and copy paste the logic itself. So for example, when we had a car and we are working with a car with automatic transmission or manual transmission, just inherit it, but not provide in your high level implementation the usage of the car class and extend it somehow with method adjustment, the logic if it's a manual transmission or automatic. So here you can use inheritance. Here you can use a composition, which we also revisited before. One important thing is using the config files or constants instead of hard-coded values. Hard codes are a code smell. In your real life, working life as a software engineer, your code will be analyzed by multiple tools. In Java, it's a SonarQube. In other languages, there are also other tools which analyzes your code. In case you are using hard-coded values like names or configurations in your app, it's being treated as a code smell. Common practices are using the configuration. So it might be the property file. It could be YAML files where all of constants being collected. Why it's important? because in many cases it's required to reconfigure your app. For example, database migrated and you need to change the URL to the database server. It does not make sense to recompile the application and change the string in your class. The class should use a config variable, and the config variable being working with some of config files or even config services. Yeah, and that's something which is also important. Please do not forget about that. I think it's clear. And the Solid. Solid has multiple principles like single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion principles. Well, covering all of them will take a lot of time, but we will try to revise at least single responsibility and dependency inversion on the example of the app. But I believe some of them already know these principles. If anyone knows and ready to explain, please raise your hand. Well, I believe single responsibility should be more or less clear. Any ideas, assumptions?
Maybe every class should be responsible for one thing.
Yeah, you are right. So if you are have the application and you have the business logic with cars, garages, owners, and other things, you need to have you need to split this responsibility among the classes. So it's a bad practice to have the one entity where you are working with everything. So, for example, you have the class which uses the logic for the car and replicate the car and also the garage for the person. That's a bad practice. It's also not readable and not understandable for users or other developers of your code. Yep, so each class, each entity in your app has a single zone of responsibility. So car is responsible for driving, switching transmission gears, open doors, and so on and so forth. Garage is responsible about storing the car. And the person may be only an owner. So person has its own methods and fields, garage, own characteristics as well as a car. Good. Open close principle.
I think it's like about streams that if you open something, you need to close it.
Well, you are close, but not enough. Any other ideas? Well, it means that your classes or interfaces should be open for the inheritance and closed for the modification. Later on, we'll probably have some time to read it more. Also, in a Canvas, I provided a short article with a description, but generally, just imagine the case we already covered. You have a car. Car is defined by multiple fields. Also, it has methods. And at some point of time, you understood that you need to have an extension in the logic and react differently if the car has automatic transmission or the manual one. The bad practice is going into the car class itself and providing ifs, changing the details of its implementation instead of using inheritance. In this case, just inherit, provide automatic car transmission, manual, automatic car class, manual transmission car class, and it would be more convenient than putting everything together in the one class car. So inheritance is a good practice. So if you are extending the logic, it's better to inherit than modify the existing class. Is it clear? Yeah, I think yes. In a canvas, you can find the example for the message formatter, and if you'll have some time, you can read in detail. LSP, Liskov substitution. I can quickly explain to do not waste the time. Generally, it says that subtypes should be substitutable for their base type without altering the correctness of the program. Well, sounds quite general, but let's imagine the case with a car in garage. For garage, does it make any difference if the car is automatic or manual transmission? I believe no. So for the garage, it's just required to have the car field. You're using the parent class car, and if it's present, so probably car is in garage. In fact, it could be the object of the class is automatic car transmission or manual car transmission. It doesn't matter. For the garage, it's just a car. So it means if it's a different types of car, if you're even substituting in one class the objects of another one, which are a child classes, it should work in the same way. Again, for garage, it doesn't matter which car it is. It should store it. That's it. And that's something which Liskov substitution principle say. So you can provide a general car, you can provide different type of cars with automatic and manual transmissions, and it will store. Any questions? Okay, interface aggregation principle, ISP. I just quickly explain. Clients should not be forced on the dependent on interfaces they do not use, or having many interfaces with just a single method implementation is better than having only one collected everything. Quick example, you have a chat. Yeah, chat may have different actions like send message, receive message, delete message, and react to the message. You can provide an interface with this set of actions. I can even quickly, I believe you can see my screen. Yeah, you can see here's a good example. Yeah, everything collected in one interface, and it's being treated like a bad practice. So much better to have the interface precisely for each of the action. Sendable, receivable, deletable, reactable, and yeah, you can see the example of a class which implements one of them. So why it's better? In case we are implementing chat action interface, you're forced to implement each of the methods. But just imagine the situation when you have the specific case when you cannot react to the message or you cannot delete the message. It's still possible. That's why we are splitting them and splitting to the separate interfaces. Why it's better? Because in case you have any kind of action in your app which should react on a send, and you need to call the send message, you just can depend on the sendable interface, but not the whole interface with different actions. So you are requiring that this chatbot or this chat application is sendable. So it means that you can send the message. There is a possibility. Moreover, it's even better to use this way in case of checking permissions. For example, the user may not send the messages due to the blockages or other things. Then, in this case, you can provide a precise action on the sendable interface. So you are splitting the concerns into the different interfaces. So the recommendation of ISP is just to use multiple interfaces instead of putting everything into the one. And in the last assignment, you probably saw this iterable interface. Okay, it has 2 or 3 methods in it, but it has split the logic. It doesn't have the add, remove, or other methods. And in case you will check the list implementation, it implements multiple interfaces as well. It could be comparable, it could be iterable, and so on and so forth. Right. We have dependency inversion principle, it's DIP. And it says that high-level modules should not depend on low-level modules. Both should depend on abstractions. And this one we will take a look, precise look a bit later in this presentation. But just here you can see the example you can also probably use in your application. Yeah, so we have the chat service, which works with the database. And as you can see here, the structure is being separated among the multiple concerns. So it has an interface like message storage, class database storage implements a message storage, file storage implement the message storage, and so on and so forth. So we are depending on the abstractions instead of using the concrete implementation, not vice versa. So first in the top, we should have interface, general interface like a message storage, and later on, you're providing the precise implementation depending on the case. In the main application, you can use a whole abstraction. It's even better because in a chat service, you are just working with an abstract way of storing the message. It doesn't matter if it's a database, file, whatever. You just need to store in case you're getting this interface. That's the benefit which brings this principle to us. Good. Let's have a precise look on a single responsibility and DIP. And as you already mentioned before, well, single responsibility principle. Each of entity, if each of the class has their own zone of responsibility. In the app, you showed in the beginning of this presentation, we have the message control and we have the message itself. Message control is responsible on the extension of the VBox and pane. So it's a visual component. So the main responsibility of the message control is just to correctly locate your component in the application. Message itself, it's the class which contains the content. So we are storing the string inside of it by using the constructor, and we can get it. So the responsibility of this class is just storing the message content, and that's it. So what we are splitting here, the one is managing UI and extends VBox and pane, and the second one manages the data. So it's simple Pojo classes. This principle is called segregation of concerns. And you are splitting here the Pojo. Pojo means a plain Java objects, and the UI component build. As you can see here, message control has only one message. And if you are creating the message control, you need to provide the message inside of it. Again, we can use a different example like car and garage. So garage has a responsibility to store the car and any kind of additional equipment. And car is responsible for car, to drive, to have the passenger, to store some goods, and the responsibilities are different. Here, in case when the car is driving into the garage, we have the relationship one-to-one. One garage has one car, but the concerns are segregated among the classes. I think it's clear for you. Yeah, so generally, it provides the understanding who knows what. In the application and even in your course final projects, it's a good idea to have the splitted concerns of the details of your implementation. So probably you will have the main application. Main application will depend on the UI, on the data itself, and on the file IO. Yeah, so With a high probability, you will be storing your messages of the chat application in a file system, or it could be a database. So you are splitting the concerns and the zone of responsibility in your app. Main applications, probably it's a main class, which has the UI definition. UI definition for the JavaFX objects declared in FXML, or you can do it by code, but it should be splitted from the data model itself. Data, it means like messages, chats, persons, users, and whatever. All of these things is dependent on information stored in a file system or anywhere else. So you need to provide an abstraction which works with a file system, for example, and which provides the possibility to store and obtain the information to the data level. In this case, if you are splitting your application in these multiple concerns, it would be much easier to understand who is responsible and what. And in case of the extension of the logic or changing, it will not require a lot of modifications in your applications comparing to the situation when everything is stored in one place. For example, if you have the task to replace file, the logic to work with the file system by anything else, like database or web services, you're just changing this connection and you're providing additional implementation. All of this stuff should use an abstractions. I think it's clear. If any questions, please don't hesitate to ask. Okay. What is a data model in our case? Well, on the right side, we already discussed, it's a message class. It has a content and it has a possibility to obtain the content and store as a string and get the information from it. Chat itself, it contains multiple messages. Chat could be named and, well, what it makes for us, it provides a name to external world. It can provide a list of messages to the outer world, and we can also add the message into it. On the higher level, we have a list of chats, and we can associate it with UI. So that's a simple data model of our application. To be clear, file IO UI, I think it's also may be clear for you. It's the logic related to the working with file system, with JavaFX components, and on the main application, you are working with a high level components. Okay, dependency inversion principle. So high-level modules should not depend on low-level modules. Both should depend on abstractions like interfaces or abstract classes. Abstractions should not depend on details. Details like concrete implementation should depend on abstractions. As an example before, the root of the application is our abstractions. Application could send the message, store the message, remove the message, and so on and so forth. So we are implemented interfaces, multiple interfaces here. All of our logic depends on them. And in our application, we are using the abstractions, which should be instantiated by a concrete implementation. For example, you are working with the storage, as we saw here. Let's check it again. Yeah, you have the chat service application. It has a storage. Storage is an abstraction. It's an interface. Your application should save the messages. Here, you work with interface and you get the message and you call in store message. This logic doesn't know anything about the details of implementation. This one should be instantiated in different locations. It could be file storage, database storage, but in your case, you should work with an abstraction. Here for the chat service from the external world, you can provide the correct or needed class instantiation object. But in this way, you are not changing the chat service in case when it was decided to switch from the file system to database or anything else. You are just storing it, and that's all. So to satisfy these requirements, you need to work with abstraction, and all of concrete implementation should be dependent on the basic interfaces on the abstract classes. In case you will be working with your course project, please pay attention on that, because the idea for the course project is just to follow main OOP principles, try to work with them, try to organize your application by following these principles. And that's actually what we will pay attention on. So if you are going to work with, for example, databases, storages, web services, or anything else, please think about the possible cases to use abstract classes, interfaces, and in the main application work with them. Okay, let's go here. It's an implementation of this application. Yeah, you have the typical chat app implemented on the JavaFX. Yeah, on the left side, you have participants, and you have here the list of messages. So here on the left side, we have list of chat controls, and on the right side, list of message controls. It's an UI representation. As you remember, message control has one message. Chat control has multiple message controls. Here it's a representation. So we are clicking the chat, we are updating this control and providing the list of messages. Let's go to the UML diagram and try to understand, not the overall diagram, and try to understand how it works. Dependency inversion principle provides a clear understanding who influences and how this influence the user action or any kind of other interaction. Before we check the storage activities, now you can see the principle here, how the system reacts on the click. Yeah, so we have application, we have the list of chats, we are clicking on them and going to the list of messages. The implementation from the code might be quite simple. We have the message list as a control with children's. We are clearing them and creating message controls with a precise message based on the chat we've clicked. So the best implementation practice is to providing an action on each of click on the chat. And in case we'll have multiple chats, just to re-implement this logic in it. The good practice is just to use an abstraction. Depend on the abstract click handler, and the click handler should be used by multiple chats and provide the same action for the recreation of the messages in it. So, yeah, how dependency inversion principle will work with this? So we have custom app, we have the chat control. Chat control depends on the message list, and custom app have one message list itself. Well, dependency from the concrete implementation is a bad practice, because you will need to react on each of changes in the message list in the chat control and adapt all of these changes in your app and adjust it even for the chat controls in case you're badly organized your code. What is required to do? We have the interface. So we have an abstract click handler. We are separating concerns, and the click reaction on the click for the chat control responsibility being switched to this interface, and chat control depends on it. From other part, we are providing the concrete implementation for this click handler. So this one depends on the abstraction. And here we can provide, we can implement the click handler and even provide a multiple implementations if needed. So chat control depends on the interface. We have a separate click handler, which probably may depend on message list. In our case, it's needed. And here we are following dependency inversion principle. So we are dependent on an abstraction instead of concrete message list class. Also, we are separating the constraints. So here we have clear zone of responsibility. Message list is just a list of messages control. Chat control responsible for the chat itself, and action for the click is splitted and reusable and could be implemented only in one place. Is it clear, or you need any questions? So in your project, you can use multiple interfaces. Don't hesitate to implement it, even with only one method. In Java, starting from Java 8, it's typical ways of working, and this interface called functional interface. So you can use storyable, sendable, clickable. You can provide multiple click handler interfaces, and depending on multiple interfaces, it's a better practice than provide tight coupling with a concrete class implementation. So what we've done here after providing a refactoring of the app. So we splitted the concerns, we provided additional interface, we provided dependency based on the interface instead of direct dependency of the message list. So in fact, we split the components and we provided additional entity like a chat click handler. So it's a connecting point between the chat control and the message list. We have here zone of responsibility for clicking, and chat control message list is depending on that. In case you would like to change the logic of or the way how the system should react on the click, you are just changing this click handler implementation instead of going into the chat control or the message list. So again, here we are also satisfying the single responsibility principle. Yep, so sample app, as we saw before, will have custom app, chat control classes, message control, chat, message, and now we'll have the click handler here. And we can go deeper into the implementation. So main members have the custom app extends the applications is the top level class structure. Has chats, chat list, message list like a VBoxes, and also it has a chat click handler. Yep, so defined in this way, I think it's already clear for you. We have the fields, vertical boxes, and list of chats like a chat object. So in case when we are listing and re-entering, we can use the for each methods and provide a lambda function. So does anyone used it before? Does anyone can explain what actually is doing here? Yes.
We use lambdas frequently in our projects and assignments home.
Yeah, so. And what is the difference comparing to the just for loop? What is the better way in your opinion?
I don't know.
I can barely hear you, but if I got it correctly, it's related to the integers or primitive values, right?
Yeah, she said that maybe it's better because we don't introduce any like indexes.
Well, at least it's more readable. Yeah, instead of providing index and some intermediate object, it looks much smaller. So actually it depends on the situation, which one you can use. This one construction comes from the Java 8, so you can use for each, you can use streams if needed. And here, new chat controls created based on the chat object. So what is doing the main application? It's create a chat with a dependency to the messages and create the control and associate the set click handler. Click handler is only one object reused by multiple controls. Yeah, so you can use as a lambda, you can use as a for each. For like a classical iterator and for cycle. This one looks more elegant in my opinion. And yeah, so if you do not have any kind of indexes, if they are not needed, you can use this for each construction. It comes from the Java 8. What happens here? We are creating the chats and chat controls based on the chat objects having multiple messages and associating the click handler. I can see someone is asking, could you please come closer to the microphone? Could you please repeat?
Nothing.
Okay.
We're talking about it.
Okay, good. Right. Here you can see the example of the chat click handler. Again, it's being defined as a lambda function. Well, chat click handler, it's an interface with a single method. Again, here you can see that using multiple interfaces is more beneficial than only one with multiple methods, because you can define it using the lambda. For Java, it's if you have the functional interface. By functional, we mean the interface with only one method. So if you're writing this function, like a lambda, it's pretty clear for Java that it's related to this method implemented in the chat click handler. What we are doing here, we can provide a sender, and we are providing the implementation. So here you can see the action, what is going on in case the user clicks on any kind of the component. Actually, it defines already the whole logic for everything in one place. So we have a sender, and sender has a message. Well, it clears the message list and providing the new messages from the chat. Quick question for you. What does it mean sender? Who is a sender here?
The user? Like the chat. No, the chat doesn't make sense. Hold on.
Yeah, you're right. Doesn't make sense.
Ciszę i bój się.
Yeah. How to answer this question? Let's go back to the chat click handler. Oh, nothing implemented here. But what we should provide? We should provide the chat itself, chat control here. Yeah. The same here for the for each. We are iterating from the chat, and chat is a precise example of the element in the list. Sender here is a chat controller which has multiple chats. It's called anonymously, I would say. So we do not have the precise class definition because it's not needed. For Java, it's already clear that based on the interface implementation. Here, probably it would be better to open the IDEA because I have it here. Okay, it's not compilable because I'm using different Java version. But here you can find this interface. I believe you can see my screen. Moreover, I'll go to the presentation mode. Yep. So here you can find it as a click handler, and it has an on-click event. By defining in this way, as you saw in the presentation, with a lambda function, we providing a sender and the action itself. So sender, it's a chat control here. It's even not needed to provide the class or interface name because Java can go to the base interface implementation and understand that this is a chat control. And chat control itself has this get chat method. And from the chat method, we can chat class, actually, we can get all of these messages. That's how it was defined. So yeah, we have our custom app, and here you can see the definition. So what is happening here? You are defining the rule only in one place as a Lambda function by defining the functional interface implementation through the Lambda function, and it will be working for all of clicks in your app. So you are splitting the concerns. You are not duplicating the code. The rule, how it works, implemented here and associated with all of chat controls and message controls in your app. That's how it should be done. So you are not duplicating information, you are splitting zone of responsibility, you have multiple interfaces, and you are dependent on the abstraction instead of the concrete chat or concrete message. In this way, you're implementing your application in most efficient way, and you're avoiding multiple duplications. I think that's clear. Yeah, let's go back to the presentation. So, additional benefits which brings to us of using multiple interfaces is that we can use them as a functional one and define as Lambda functions here. Good. Yeah, so here what I've already displayed, how the chat click handler looks like. It's only the interface with the one method. It accepts chat control, and we can define this implementation, and we are defining actually it here. Sender is a chat control. Good. Actually, it's 11:47. I don't know if Sergey joined or not. Valentina, Sergey, are you there?
He showed up near the door, waved to us, and then left.
Okay.
Notably, the books and the crumpets and I guess tea we have.
Okay.
We brought them there, lying in the corner of the class. You probably don't see them because the camera is not pointing that way.
That's right. I can see the audience. Good. While he is making a coffee, probably, I have. First of all, I would like to ask you if you have any questions. Do we need to reply and review these details of the implementation? In a canvas, you can find details of the solid principles. Please take a look to revise. Moreover, I believe we will have the time for the consultations in May to answer all of your questions, provide initial review of the course projects, and please try to follow all of these principles in your app, because this exercise is just to make you clear and understandable how to use OPA, OOD, and Solid, Yagni, and other things. So please try to use it in your course project assignment. I believe you'll have any other questions. We'll have a time before the May to answer them and adapt your app.